Hello there, everyone. I am doing a video to help you prepare for exam two. Interesting times we live in. You can see that I am in what's called student view in my Canvas, and that's just so the screen appears just like you guys will see it. It is currently, what day are we? I am on March 20th here. It's about 10 o'clock in the morning. And I wanted to put together a little video about the review. I will be going over this with you guys next week in class, in virtual class. Air quotes there you can't see. But wanted to show you where the review material is located at. Now, as far as the exam itself, I will have a separate correspondence with you, and it'll be probably a video showing you how to access the exam. I'm sure there'll be a link, something called exam information, exam one or exam two, excuse me, will show up there, and it will take you through. You're going to be doing an online exam. I intend to use the Proctorio Integrity software, which I have to learn more about, but you'll need a webcam and a microphone, and the built-in camera you have in your laptop will suffice. If you don't have a camera, you'll need to get one at I'm sure you can get one off Amazon or go to Walmart, probably go to Amazon and have them email or send it to you. I would do it sooner as opposed to later. It shouldn't cost you more than 10 bucks. But you're going to need this for all your classes, so grab one while you can. Anyway, let's do the review, and then I'll be on live next week, live in a virtual sense, with some Blackboard Collaborate Ultra. I'll do a separate video showing you how to use this as well. But again, you guys are probably more skilled in this than I am. I've used it before. It's easy to work with. It's effective. But you guys are going to be using it for all your classes, so you'll be more the pros than me probably. Anyway, let's get right into it. So let me go down to Exam 2 Review, and you're going to see several different things here. You're going to see some homework answers. I have some suggested problems that I like. You should like them too. And then practice exam answers. And there are good questions. Those are good examples of questions I'm going to write in the online exam you're going to be taking. So let's do it this way. Let's see if I can make this work. Let's make this a little bit bigger. I'm trying to stay within the screen. That'll work. It ain't pretty, but it'll work. So your exam 2 is going to be during regular class time. So I'm not sure how I'm going to do that. I guess I'll figure that out. But you'll be taking the exam during your regular class. You'll have 75 minutes. There'll be 20 multiple choice questions, formula sheets, normal table, t-table. The exam's going to be really, really long because I'm going to have individual questions. And when you use those tables, I'll put those tables up for you to see. I'm not exactly sure how I'm going to do that yet, but we'll figure it out. Sure we will. The Proctorio doesn't allow you to use notes or books or anything like that, so I have to provide everything with each of the questions. So that's my responsibility. Don't worry about that. I'll figure that out. No pencils are necessary. Calculators, okay, although I'm going to try to write an exam where you don't really have to use a calculator all that much. And guess what? Picture ID, you don't need that either. This was written for another time. Remember the antiquated times when we actually met? Yeah, so, whoops. Extra homework problems. Here's some ones I really like. These are from the textbook. In question 6.39, the first part I think says find the interval. I will be giving you all printouts, so you don't have to do any of that math at all. So those are some problems that I really, really like, and you should like them too. All right, here are the topics. Chapter 4, you should be able to do normal problems. There's a probability problems like 3B on the project. Point in the distribution problems, the X naughts, find the 10th percentile, find the point in the distribution that represents the upper 20%, where I give you a probability in US, or I ask you to find a specific value of X. And then you should know about assessing the normality of a distribution. You looked at the empirical analysis on your project. There are 3 other types of assessments as well. You should know those. You should know what those are. Speaking of your projects, I can't return them. Yeah, this whole limiting face-to-face doesn't work, so I posted an answer key to the project as an announcement, so you can see at least what the right answers were. In future projects, you'll be submitting them online. We only have project 3 left, but you'll be submitting that online. We'll be grading that online, and you'll see exactly what you missed. But on this one, you're just going to have to take a look at the answer key because we don't have the ability to get them and meet face to face. Anyway, moving on. So normals, chapter 4, normal, normal, normal. Chapter 5, sampling distributions. You should have a general understanding of what a sampling distribution is. And we talked about the 4 different pieces. You take a sample, you calculate a statistic. So think about question 3 where you gave me the average closing price of your 65 stocks. You took a sample, you calculated a statistic, an X bar value. The other 2 pieces which you haven't done, but which are part of the sampling distribution idea, is you do it again. So take another sample, calculate another value of X bar. You do it again, and again, and again, and again, and again, and you pile up those X bar values. That's called the sampling distribution. Now, you've done one sample. Collectively in the class, I think about 265 or 270 projects were turned in. So we've done it again a whole bunch. If I took all those X bar values from question 3 and put them on a number line, that would be the beginning of a sampling distribution. In theory, you're going to do it forever. That's the theory. We know certain things. We know the shape when we take a large sample, 30 or more, when you're working with means, n times p and n times q both greater or equal to 15. When we're working with proportions, we know that the shape is approximately normal. So when we talk about the sampling distribution of X bar, 30 or more is what we use for the shape. We know that if we have a small sample and the population is approximately normal, then the shape will be a t-distribution with n minus 1 degrees of freedom. We learned that in chapter 6. But here in chapter 5, when we're working with large samples, the shape was approximately normal. The mean is mu. The standard deviation of the sampling distribution of X bar is sigma over the square root of n. And then we learned about the central limit theorem. That's what got us to the approximate normal shape. And we could do some X bar probabilities. So there are X probabilities and X bar probabilities. All of them are normal. And you just need to be able to work those out. And we looked in class at how we determine whether we're working with an X or an X bar. The general rule or direction is assume that the normal problem is an X unless you see a sample size and some mention of an average, and then it's an X bar. In chapter 6, let's see if I can put this. I guess you don't need to see chapter 6. Whoops. Let's see if I can scroll this a little bit better. Now, if my screen is right, that should be on your screen right now. Chapter 6, we have confidence intervals for mu and p. The only thing you're going to need to do is find z and t values in a table. I'm probably not going to make you do that too much because that means I'm going to have to copy those stinking tables over and over and over again. And that's going to make for just more work for me. So, very few calculation problems. What do you guys need? You need to know the sample size criteria. There's 2 of them, as I just mentioned. 30 or more for means. N times p and n times q both have to be at least 15 for proportions. A little bit harder to work with, or remember, or write, but there's just different sample size criteria for different parameters. What am I going to be testing you on? Interpretations. Take a look at your projects. That's funny. Take a look at what I asked you on your projects, because you can't look at your projects. I asked you a practical and a theoretical interpretation in question 1. And then I gave you a question, or maybe I expressed it as a claim. I claim that the mean is $20. What do you think? Well, I'm asking you, is mu equal to 20? You did that in question 2 for me. So those are the types of interpretations you guys are responsible for. If the interval's too wide, it's typically, no one says, hey, we want less accuracy, let's make it wider. Usually it's, we want the interval to be narrower. We have 2 different methods of accomplishing that. We can increase the sample size, or we can decrease the confidence level. Doesn't matter what parameter we're talking about, means, proportions, things you're going to see in a Stat 2 class and beyond later on. Those are always our 2 tools that we have available to us when we're working with interval width. And then assumptions. If we have large samples, and let me be clear here, we always need random samples. Now, I didn't have you state that, or I didn't make you state that on your projects because I knew you took a random sample from the first part of the project. But we need a random selection of data for everything we do. In addition, for small samples, like we had in question 2 when we were working with 25 NASDAQ stocks, and because we were working with a mean, 25 is less than 30, so it was a small sample. When you have small samples, we need the population that we're sampling from to be approximately normal. We need the high prices of all NASDAQ stocks to be approximately normal. That was the wording that I was looking for on the project. Not the mean high price. The mean high price is just a fixed number. We need the high prices themselves, the X's. X's are individual values. X bar, what you see on the printout, if you have the mean sitting there, that's the sample mean. That thing's going to move around depending what sample you take. But the mean of the population is a fixed number we don't know. And that's mu. X bar is the mean of our sample. The individual high prices themselves were the X's, and it's the assumption. The assumption is the population of x's needs to be approximately normal. So that's our what I will refer to as our small sample assumption. When we get to chapter 8, we're going to see a couple new assumptions, but we'll get there in due time. And then the last type of problem that you guys are responsible for on the exam are some sample size problems. Sample size problems are, I'll give you how wide I want the interval to be, and usually it's referred to as the to within amount. I want to estimate the mean to within $3. I want to estimate the proportion to within 3%. That's the margin of error. That's the part that goes in the denominator down here. I don't know if you can see my cursor. No, that's not working real well. Well, the ME, that's the margin of error. And you just plug numbers into the formula. One thing, I need to give you some kind of estimate of a variance in this first formula, the sigma squared. I either need to give you some estimate of that or an estimate of the standard deviation that you square, or you need estimates of P and Q. And the nice thing about when you're working with the formula over here, and I'm just messing around with it, it's turning purple on my screen. Hopefully you see the same thing. But if you don't know the values of P and Q, that's when we plug in a value of 0.5 for each of them. And we figure out the sample size based on that. If you have a value of P and Q, you plug it in. If you don't have a value of P and Q, you use 0.5s. And that, my friends, those, my friends, are the topics for your exam. I'm still working on exactly how I'm going to do it within Canvas, but I'll figure it out. Please, please, please don't stress out about this. We will make it through the semester. I promise you. I will work with you. I will make sure you guys have everything you need. And if there's technology problems that come up along the way, we'll just fix them. I'll work with you. This is unprecedented for all of us. The good news is, at least in my class, we've done this. We haven't done the exams, or at least you haven't done the exams. I have done online exams before, but you guys haven't done online exams in my class, but you have done online lectures. You know how I post notes. You know how I tend to run the class. So I'm going to do more of the same. So hang in there. It's going to be okay. Make sure you are staying safe, and if not for yourselves, for the older people in your lives, because they're the ones that get affected. My generation and older are the ones who are a little bit more affected by this thing, apparently. Although some recent research is indicating that maybe that's not the case. Either way, protect yourselves. Wash your hands. Don't touch your face. Do that stuff. And yeah, we'll get through this. I promise you. This will be that pointer. Where were you when? Where were you when the coronavirus came out? And this will be something you look back in your life and you'll be like, whoa, those are crazy times. At least I hope these are crazy times. Hope these aren't the calm times before it gets really, really crazy. So hang in there. Tell somebody you love them today. Hug your animals. Pet your dogs. Love on your cats, or do whatever you do to cats. I'm not a cat person. And try to look at something you can be grateful for today. And so I'm grateful for you guys being patient with me. Yeah, that's all I got about that. I'm rambling. Sorry. There's your review. I will talk to you guys in Blackboard. What's it called? Blackboard Collaborate Ultra? Yeah, I'll talk to you guys in that soon. Log on and let's get her done. Hopefully you guys are having a good day. Talk to you later.